Alright everyone, welcome back to the Foamy Fizzy Fluids in Houdini tutorial. In this lesson we're going to start going over how to work with our foam points so that we can get something we can render. In our last lesson we cached out our simulation and we did a little bit of editing to it post-simulation, getting rid of some stray particles as well as bending the initial pour a little bit to give it a little bit of a nicer shape. So right off the bat I'm going to go ahead and isolate our foam points. Just going to use a delete for that. I'm going to grab our foam group and do points and delete non-selected. So we can just call this isolate foam. And then just for organization's sake, I like to put down a null just so it's big and clear when our network gets a little bit more busy. So here, foam. So this is where our foam points are coming in. So if we scrub through our timeline, you can see we have all of our foam points. And I'm going to go to the last frame, and here you can see we have a lot of foam points that are still at the bottom of the glass. We did add all those forces in our simulation to start pushing up the remaining particles to go towards the top of the glass, but even so, with the current length of our simulation, not all of them got to make it to the top. So what I'm going to do is, much like our stray particles, I'm actually going to get rid of these foam particles, and the reason I'm doing that rather than just letting them render as is because I plan to make my own separate simulation for rising bubbles within the liquid, so we have a little more control over those specific bubbles. So to remove these points, I'm going to do the same thing I did with our stray particles, and I'm going to remove them by ID. And I'm going to do that while I'm on the last frame, so that we're just grabbing the points that are still at the bottom on the last frame. I don't want to grab them somewhere in the middle, because maybe some of these points make it up to the top, and I don't want to remove those. So on the last frame, we'll go ahead and hit S to go into selection mode, turn back on point selection, turn on our group, and it still has the ID attribute from when we last used our group selection, but if you don't have it, you can go ahead and just type @ID in the text box of the group select. And I'm also going to switch over to lasso select just so I have a little bit easier control over the shape. Now, if I were to just do it from the current perspective and just kind of, grab some points like that, hit delete, you can see we have a really hard line here from where we deleted. And if we scrub back on earlier frames, it's not as noticeable. We don't see that hard line. It's just on this last frame. Everything has settled into the frame where we've blasted our points. Our selection is basically projected out from the camera, so we're getting this hard line from the shape we drew. So instead of selecting from the camera view, I'm actually going to just open another tab, and I'm in a perspective viewport, and I'm also going to template our glass object so that we have a feel for where we are in relation to it. So I'm just going to pan around, get a different perspective from our camera sees, and I'm going to hit the little arrow on our blast node to change the selection we currently have. I'm just going to click here so that it unselects everything that we had before, and now I'm just going to select the same general area, and I'm also going to do a little bit of a jaggy motion here just to get a little bit of a less hard line there. And let's hit enter. You can see from the perspective we selected from, since it's projecting out from our current view, this is a hard line. You can see in our camera view it's not a hard line anymore. Now we have kind of a nice little bit more natural shape. And if you feel like you still don't have a shape you quite like, you can always just go ahead and select and add or subtract more points. You can move around your viewport some more and try to grab another selection of points and just kind of vary it up. But for what we're doing, I think what we have here is fine. So I'm just going to go back to one viewport. So now by the final frame of our animation, we'll only have foam points at the top of our glass, on top of our liquid, which is what we want. Now that we've gotten rid of those points, we're going to divide our points into groups a little bit further. And what I want to do is I want to isolate the points that are on the outside of the foam. So if I pan up, I want the points that are closest to the glass and the points that are on top of our foam. And I want to isolate those points to be used for bigger foam bubbles. Even though we've cached out our simulation and we're pretty happy with our movement, it's still important to look back at reference. So you can see here a macro photo of foam bubbles in a carbonated beverage. You can see that the foam is largely made of smaller micro bubbles, but there are larger bubbles interspersed throughout that kind of vary in scale. And the points I'm isolating are going to be used for those larger bubbles. And the reason I want only the points that are along the edges and along the top, rather than just randomly assigning certain points to be large foam bubbles, is that these larger bubbles are going to be geometry. There's no point creating those geometry bubbles deeper inside the foam since they'll be obscured by the micro bubbles. The way I'm going to isolate these edge bubbles first is with a quick attribute transfer. And what I'm going to be transferring is the color between the glass and the points. So I'm going to scroll back up to where our glass is, and I'm going to put down a color node. I'm going to set it to black. And in addition to this color node, I'm also going to put down a subdivide, because the attribute transfer is going to be comparing points, and the initial glass object doesn't have that many points, so subdividing it will give it a little bit more accurate results. I'm going ahead and turn the subdivision level up to 2. So we have lots of points for it to sample from. Then we can go ahead and connect this down into our attribute transfer. And you can see on our attribute transfer, all of our points have turned black, and that's because at the default values for attribute transfer, it's by distance, and the distance is set to 10, which is 10 meters. So obviously, all of these points are picking up all of the color of the glass, so we need to turn this value way down. So I'm going to set it pretty low to 0.005. So now you can see, if we pan around, we're getting a nice kind of shape here where we're only changing the color of these outside points. But there's also kind of a harsh line in the middle where we're getting back to our white points. So I'm going to increase our blend width so that we get a little bit of blurring of the attributes between here. So I'm just going to increase it ever so slightly. So now you can see we have a nice fall off for the points that are getting that color. So to isolate those points, I'm going to use a point wrangle. And I'm going to call this group small bubs for the small bubbles. And I'm going to go ahead and create the group. So at group small equals 0. And then I'm going to set up an if statement for the color. So if the color is greater than 0.1, we'll set the group small is equal to 1. So now we have created a group called small, and for the points that have a color greater than 0.1, they'll be added to that group. So that way it's grouping those points in the middle. And then if I put down a delete, and I'll call this isolate outer, and I grab small points, you can see it's gotten rid of those white points, and we have just those points that are on the outside rim of our glass. Now you might remember I also wanted to grab points that were on top of our foam. I didn't just want these outside rim points, I also want to be able to see large bubbles sitting on the very top. So I'm going to have to incorporate that into our selection process. So to do that, I'm going to go back up to where our attribute transfer was. I'm going to put another node down. I'm going to put down an attribute create. I'm going to call it get top. I'm going to create an attribute called ymax. I'm going to set the precision to 32-bit. And the value will be $ymax. We go over to the geometry spreadsheet, and then under attributes, we'll just type in ymax, so that we're only seeing that attribute. You can see it's returning the value that is currently the highest in the Y position. And we're going to use that to isolate the points that are nearest to the top of the foam. So back in our scene view, we're going to go to our wrangle, and we're going to create a few channels. So first we're going to create upper, and it's going to equal the ymax plus a channel that we'll call radius. And then we'll create an attribute called lower, and it will be the ymax minus a channel we'll call radius. So that way it is the same channel being used for both of these attributes. And then in our if statement, we're going to incorporate these values. So if the color is greater than 0.1 and the lower value is less than the position at Y, and the position at Y is also less than the upper value. This way we'll be isolating a set of points between these upper and lower values here. So let's go ahead and click this to create our channels. Scroll down to our radius, and I'm going to display our delete so that we can actually see what it is we're isolating. And let's increase the radius. So now you can see we're getting those upper points. So I'm going to set it to something kind of small. Let's do 0.01. So now you can see we've got the sides as well as this little top area for our larger bubbles. And then again, just for organization's sake, I'm going to copy this little foam identifier, and I'm going to put it here and call it big bubbles, just so it's easy to see that this is where our big bubbles are. So now we've isolated all of these points to be used for large bubbles. But if you think back to our reference, there weren't that many large bubbles. They were pretty interspersed. They almost weren't touching because there were so few of them compared to the overall foam. So while we've isolated the points in the positions that we'd like, we have way too many points for our large bubbles. So we're going to reduce the amount of points we have. So I'm going to put down a point wrangle, and I'm going to call it reduce amount. I'm going to write an expression that we can use to randomly delete a certain percentage of our points, as well as create a seed attribute so that we can vary our selection. And if I'm being honest, this is probably the expression I use most often across any effect that I'm creating in Houdini. So I'm going to do if rand at ID, and then I'm going to multiply the ID by a channel called seed. So this is going to return a random value between 0 and 1 based on the ID, and we're adding a seed attribute so that way we can vary up our selection. So if this value is greater than a channel we'll call threshold, do a curly bracket, we will remove the points of our inputs on the current point number, then do another curly bracket. Let's go ahead and hit this to create our channels, and immediately everything disappears. That's because our threshold is set to 0. The threshold is working as a percentage, so if it's set to 0, we're keeping 0% of our points, and at 1, we're keeping 100% of our points. We also want to change our seed so that it's not 0, because obviously if the ID is multiplying to 0, we're going to get the same value for every point. So let's just drag it to some random number, and then we can start playing with our threshold to see how many points we want to keep. So I'm going to keep a pretty small amount of points for now. Set it to 0.03. Then again, I can mess with the seed if I want to have a different selection of points. Even though we specifically isolated points that are towards the outside of our foam as well as the top, they might still get lost inside our micro bubbles. So I actually want to push all these points out a little bit. And the way I'm going to do that is I'm going to use the normal of our glass and push them out based on that. So to do this, I'm just going to put down an attribute transfer. I'm going to call this get normals. And then using the same thing we were doing with our color, I'm just going to put down a normal because I don't believe our glass had those already. No, they did not. So I'm going to get a normal. And I'm going to set it to points since that's what we'll be copying this value to. I can go ahead and drag this down here. We can go ahead and preview this, and just to see if we've got our normals, we can display normals. So you can see we have all of our normals pointing outwards as we might expect from our glass. And I'm just going to turn that off so we can see what's going on better. I'm going to put down a peak, and this will just push the points based on their normals. And you'll see really quickly that this is a pretty sensitive slider. It's pushing the points way out into space, so we want to do a pretty small value. So I'm just going to do -0.002. So now if we bypass the node, you can see that we've pushed them out ever so slightly. Might even want to do it a little bit less so that they're not touching the glass. Maybe something like 1/5. It's just a little bit extra to make sure that they won't get lost inside the micro bubbles. Now that we've pushed these points out, we're going to turn these points into bubbles. So to do that, first I'm going to put down a VDB from particles. Plug that in. And we can't see anything because of the scale of our simulation, so I'm going to turn our minimum radius down to 0, and our voxel size is going to be extremely small. And also need to switch our viewing mode over to smooth wire shaded because you can't see VDBs when you're in a wireframe mode. So now you can see we have our little circles for our bubbles. And you'll probably notice that they're not only a little bit larger than we might like, they're also all the same size. So even if we're adjusting their scale here on the VDB node, we still have the issue where all the points are the exact same size, which isn't true to life and isn't as interesting to look at. So to make our bubbles less uniform, we're going to randomize their p-scale. So to do that, I'm going to put down an attribute randomize, and we're going to plug that in, and I'm going to rename this randomize p-scale. And we want to change the p-scale attribute, and we want to change the operation to multiply. Because we already have a p-scale, we don't need to set it here. We're just going to multiply it by a random number. And then over on the Options tab, I'm going to set the seed attribute to ID. So that way the random scale is based on the point's ID. So we can go ahead and plug this into our VDB node. You can see we now have randomized size of our bubbles. And while this default randomization does give us a variety of sizes for our bubbles, if you think back to our reference image, you can see that while we do have some randomness between the bubble sizes, within the larger bubbles, a lot of them are actually pretty similar in size. You can see that there are a lot of bubbles that are smaller and have a very similar size, and then there are outlier bubbles that are larger. This distribution of scale can often be described using the power law. What the power law basically states is that in nature there is a visible contrast between some value. In our case, this refers to the bubble size. So there are small bubbles and there are big bubbles. However, fewer of those bubbles will be large, whereas a lot more of them will be a similar size on the smaller end. So we want to implement the power law into our scale. And the way we're going to implement that is in our distribution on our randomize node. I'm going to change our distribution to a custom ramp. So now you can see we have a custom ramp from 0 to 1, and visually we haven't really changed anything yet, and that's because our ramp doesn't resemble the power law we just looked at. If we expand this, we can take a look at the curve we have right now. So I'm going to start off with this first point, and this is at a value of 0, which means the smallest particles are having their p-scale multiplied by 0, which I actually don't want. I don't want them to be infinitely small. I want them to have a minimum value that we can still see. So I'm going to set this to 0.3. The default value of the second point is 0.5, which I'm actually going to leave as is, since that's pretty similar to 0.3. However, I am going to drag it over to the side so that more particles exist in this range of 0.3 to 0.5. So now you can see that we still have a variation of scale between our bubbles, but we have a lot fewer large bubbles, and it creates a more realistic contrast in our foam. You might be wondering why I didn't simply just copy spheres to our points to use as geometry for our bubbles. And that's because if you zoom in, you can see that some of the bubbles are so close that they intersect and touch a little bit. And for those bubbles, I don't want to just simply have intersecting sphere geometry. What I'm going to do instead is I'm going to put down a VDB smooth. At default, the smooth is a little too strong. We're losing some of our bubble shape. So I'm actually going to turn the iterations down. I'm going to turn them down to just 2 iterations. That way we still have our separate sphere shape while we have a little bit of blend between bubbles, similar to how you might expect bubbles to interact in real life. Then after we've smoothed that connection, I'm just going to convert our VDB to polygons. Change it to polygons, and now we have our geometry for our larger foam bubbles. One last thing to keep in mind is when we converted our particles to VDBs, we didn't save any of our attributes. So now if we middle mouse on our converted VDB, we've lost our velocity, our IDs, and all those other useful point attributes we had. So we're going to want to transfer those over to our new geometry. So we'll again be using an attribute transfer. And since this is just for rendering purposes, the most important attribute we need to grab is the velocity, so that it has accurate motion blur. So I'm just going to call this getV. And then we're just going to hook in our points. And we can go ahead and display this, and we're going to select the velocity. And if we want to preview that, we can hit the point trails right here. And we can see that they are receiving velocity values. And then finally, I'm just going to copy another null down here. And I'm going to call this out big foam. This way I have a node that I can easily grab for rendering our large foam bubbles. Since we're using such a small voxel size and processing a decent number of points, you might want to cache this out. So I'm actually going to scroll up to where we created this cache for our sim. I'm going to copy that and just drag it down here. And I'm going to rename the node, because if you remember, I set up our file cache node for the sim to rely on the name of the operator. So I'm just going to rename this to Big Foam Render. Then I can go ahead and save it to disk. Alright, with that cached out, we can go back up to where we broke out our larger bubbles, and we can start working with our smaller bubbles. So we can go ahead and display this wrangle where we broke out the two separate ones. And I'm just going to drop down a copy to points, and I'm going to create a sphere. And I'm just doing this for preview purposes so that we get an idea of what we're dealing with. So again, immediately you can see our bubbles are too big. So what I'm going to do is go ahead and copy this randomized p-scale that we already created with the ramp that we want. I'm just going to plug it in right here. And we don't want our micro bubbles to be quite as large as our large foam bubbles, so I'm going to turn down our maximum size to say about 0.7. So we still have variance in scale, but we don't have as drastic a variance. And I'm also going to turn down the global scale slightly, say to 0.9. So that way overall these bubbles are smaller than our geometry bubbles. I'm just using this copy to points to visualize the scale of these bubbles. We're going to be rendering them as points, and they'll render as spheres at render time. Now that we have the scale of our microfoam sorted out, one more thing I want to do is get rid of the points that intersect with our large foam bubbles. And I want to do this because I don't want to have tiny bubbles rendering inside our geometry bubbles. It could create noise and just won't look right. So to do that, I'm going to put down a group node. And I'm going to hook in our points. And I'm going to bring this down. And I'm going to connect our cached out geometry bubbles into the second input. Go ahead and preview this. I'm going to change the group type to points. I'm going to change the group name to intersect. I'm going to turn off the base group. And I'm going to turn on keep in bounding regions. And switch the bounding type to bounding object. This way it is selecting the points that are inside of our larger bubbles. And then with those points selected, it's as simple as throwing down a delete and removing those points. So now when we render, those points that were existing inside the geometry won't show up. And then again, this might take a bit to compute on each frame, so you might want to cache this out. So I'll just copy over my file cache, and I'll just call this Lil Foam Render. And also create a null for this. Out Lil Foam. Then I just need to cache this out. Okay, now with the small foam points for the microfoam and our larger geometry bubble foam cached out and ready to go, we are essentially done setting up our foam points from our simulation so that we have something to render. In the next video, we'll start working with our liquid points and start meshing them so that we have polygons to render. In addition to the liquid, we'll also look into creating additional simulations, including the little fizz at the top of the champagne and additional bubbles rising inside the liquid.